Thanks for watching Engineering Physics 2. I wanted to talk to you today about something very important. Why is physics important? Why is science important? I think fundamentally the reason is because it allows us to determine if something is real. Science fundamentally tells us if something is repeatable or not. Now, that might not necessarily mean anything, but one thing I faced in college was I took many different philosophy classes. And one of the big questions in philosophy is, how do we know if something is real or not? Now, if you have read about Descartes, he struggled with the question of whether or not he was real, or if anything is real. And the conclusion that he ultimately came to was that he can't tell if anything else is real. The only thing that you can be sure of that's real is you, yourself, because you are thinking about things, you are aware of other things, and since you are thinking, you must be real, because if you weren't real, you wouldn't be able to think about it. Now, he came to the conclusion that beyond that, you can't know if anything is real. Literally, there's no way to tell. Just like this glass of water here. I think it's real. I think I'm holding a glass of water. When I drink it, it's cold and refreshing. But how do I know that it's real? Your brain is connected to your hand through electrical impulses. But what if I'm actually alive 300 years from now, and robots, just like in the Matrix, have hooked me up to a big computer, and they're feeding me these impulses to my brain, and those electrical impulses are so convincing that I literally can't tell the difference between reality and simulation. One of the questions that I've been dealing with the quantum computer is, in a quantum computer, it would be possible to create a quantum state, which has the same quantum state as something that's real. Now, you can do this with molecules, so you could hold the quantum state of a molecule inside of a quantum computer, and if quantum computing is successful, it would mean you wouldn't actually need the molecule. You would actually have the same quantum state as you do with the molecule inside of the quantum computer. Now, does that mean that that quantum state is not real? Is it real? What is that quantum state? Is it possible that you could exist, or something could exist as a quantum state without the actual matter to go with it? And maybe matter is just some type of quantum bits that hold those quantum states. So the thing that's real is not the actual matter, but it's the quantum state. So if we say that it's the quantum state that's real, then whatever you hold that quantum state in is irrelevant. And so really, now we're in a whole new world of trouble philosophically, because maybe I have this phone, but maybe I'm actually in a quantum computer. And would my reality be different if I was just merely a quantum state that was being held inside of artificial atoms in a computer? That I don't know. For all I know right now, maybe in the future they've developed some truly advanced quantum computer where they could actually process whole worlds or Earths, which is not inconceivable because you'd only need 300 qubits, and then you'd have more bits than there are atoms in the entire universe. So then we could think, now we can see what a quantum video game might be like. It might actually be a world inside of your quantum computer. Is it real? Well, it could have the same quantum state as something that was in the real world. Now, that's a little bit scary to think about, that we might just be quantum states. But that would only be possible if fundamental science and physics is real. Because if at some point I made the decision that I'm going to subscribe to the naturalist philosophy. And that is the idea that if something is repeatable, then that means that it's real. I can measure it, I can perform an experiment, I can collect data, and if I do the same experiment 100 times, I'll get the same result. If I drop this battery 100 times, then it's going to accelerate at 9.8 meters per second squared. That will not change. And that is what we would call real. That's science. That's what physics is making an experiment to measure reality. And if I were to come along to you and I would say, I don't believe in physics. That's crazy science stuff. I think things fall at 5 meters per second squared. You'd say, well, I can prove it. I can prove that this is real. And that is the basis of science and how we can tell if things are real, because they're repeatable. That's not to say that you can't believe in things based on faith alone. And that's not at all what I'm trying to say. But what I am trying to say is that if you read something on Facebook about science or religion or politics, that doesn't mean that it's true. If you read something on Facebook, you have to verify it. And if Facebook contradicts something that we know is true in physics, then we might want to question things that we read on Facebook. And I don't know if you've checked YouTube lately, but there are some things that people say that might go against what we know in science. And so then you might question, well, if these things contradict science, basic science, then you might question those sources. So we have established that germs, for example, are real. We know that germs indeed make people sick. This is something that we've known for about 100 years. Before people knew about the germ theory, there was one particular doctor, Louis Pasteur, over 100 years ago, proved that germs are real, which is why our milk today is pasteurized and it doesn't kill you. So at the time, the germ theory was very controversial. People didn't believe in germs. They thought it was a bunch of nonsense. And one of Pasteur's idea, after he studied the fermentation process, was that germs could be transmitted through the air, which contributed to the spread of diseases. This was Louis Pasteur in the 19th century. And since then, that was very revolutionary. And he eventually convinced people that germs are real by an experiment where he took a drop of blood with a sheep that was dying of anthrax. And he was able to eventually grow the anthrax in a petri dish. People question, well, was it real, or maybe he got some contamination from the sheep in there? But he repeated the process until there was no more blood left in the sample anymore, and it was really just pure anthrax. So the experiment that he used to produce this was by making anthrax, which, as you know, can be used as a weapon. But this led to the idea that hospitals needed to be sterilized, because before then, if you went to a hospital, it was almost a death sentence. You would most certainly get some other disease from other patients that were there, because doctors didn't wash their hands, they didn't sterilize the scalpels, so they would literally operate on one patient who was sick and then go immediately to another patient without washing their hands or sterilizing any of those instruments. And so, yes, obviously, whatever they had, you would get, and you would also die. So, because of the discovery that germs are real, we have saved countless lives. And we also now know that germs can be passed through the air. And if that wasn't true, we wouldn't be able to ferment wine or beer, because that fermentation process can't happen unless you get exposed to dust in the air, which allows the fermentation process to begin. So, what did Louis Pasteur prove? That germs are real and that they can be transmitted through the air. And somehow, 100 years later, we have forgotten that. But every time you drink milk, just remember that your milk is pasteurized, which was named after our good friend Louis Pasteur. And yes, indeed, germs are real and they can kill you, which is why non-pasteurized milk is illegal, because it's actually very dangerous. Thanks for watching. I hope this helped, because without science, we can't really prove anything is real. And I don't even know if I'm sitting here talking to you. I don't know if this computer's real. I don't know if I'm sitting in a chair right now. I could be in a quantum computer 500 years from now.
Thank you, like and subscribe down below.